And today we are going to cover the relationship between customer service level and then the sales. Okay. This figure basically presents this relationship, and you may find some other examples which do not fit this graph where we have a decline. Okay. There are three different regions in this graph. The first one is called threshold area. Basically, you are trying to match your competitors' customer service level. Okay, when you have very poor customer service level, you cannot have any sales. As you start matching your competitors, you see an increase in the customer service level. Then we have a range of transition, which is basically a gray area. This is not a 0-1 game, so you think you match it, but there might be a region more than a number to match. So you have to improve a little bit before your customers prefer you rather than your competitors. Okay. Once you clearly outperform your competitors, you enter into the diminishing return area. The reason we call this diminishing return is initially when you make a change, you see a bigger improvement. Let's say I increase my customer service level from 60% to 63%, 3% increase, and I see this much revenue increase. Okay, if I try to do the same improvement later when I have 80% and 80% to 83%, although I made the same improvement in my customer service level, I have a fraction of the initial improvement. So that's why we call it diminishing return area. Initially, you get bigger benefit. As you go in the higher levels to your gain goes down. Okay, and then the last area is called decline area, where you are improving your customer service level but you are losing customers. Okay, I'm gonna give you an extreme example for a sales organization. Okay, let's say there is a sales company, industrial distributor. They have one salesperson visiting 120 customers. Okay, and this person visit one customer a day. Okay, so each customer is visited once every 4 months. Okay, now, and you see this this one person is not enough to build this relationship, so you decide adding another person and sharing this 120 customers as 60. And again, each sales rep visit one customer a day. Every 2 months they visit the same person. Okay, so you saw an improvement in your customer service level, and you saw an increase in the revenue. So you decided to, let's say, add 2 more. Okay, now you can visit every 30 days, and your customer service is going very good and your revenue is improving. But you are so excited about the situation, so you decide to add let's say 100 more. Okay, I'm just exaggerating, and you are visiting almost every day. Okay, basically you are at this customer's location. Is that gonna improve your sales? I bet no. So when you pass a certain threshold value, you start bothering your customers, okay, in terms of customer service level, and then you may lose your customers. We feel this we can see similar situation in our real life. When you go to a restaurant, you may see some servers coming to your table every minute, where you start feeling that they are bothering you, and that is a high customer service level, but it's not very effective. You will be also not happy if a server comes at the beginning and doesn't show up again. So there are two extremes, and you will be bothering your customer in 2 cases. Okay, so you may actually increase your customer service level but reduce the sales, so you need to be careful. Okay, so if I go to this relationship graph, the question is, what is this graph in real life. Unfortunately, it is impossible or practically impossible to come up with this actual graph, so we need to come up with some ideas. Okay, there are a couple of ways of coming up with this sales customer service level relationship. Okay, one thing I need to mention is what we are gonna do is in this graph looking at the diminishing return area, because this is the place I get most of the sales. I'm gonna look at this area and try to come up with some ideas. Okay, the first one is called 2-point method. Okay, in this one basically what you are going to do is you will have two different customer service level in the diminishing return area. Let's say this is the first customer service level and you observe the result. Okay, this is your CSL, this is your revenue or sales. Okay, and then you observe this one as well. You draw a line and say this is my customer service level. Okay, line. Okay, and the reality is we don't really know, but we are trying to estimate. Okay, and the second one is before and after experiments, where you may have some previous data. What was your customer service level and what was the corresponding revenue, and then you probably you improved your customer service level in terms of delivery time, on time deliveries, and so forth. Now you have a new revenue and you can see what is the corresponding customer service level, and then draw a line and again assume that relationship holds. The next one is game playing basic. You try to put a couple of people in a controlled environment and ask them or play certain games which simulates the customer's buying experience, and you try to come up with the customer service level curve. Okay, and then the last one is, which is very commonly used, basically you prepare some questionnaires, do face-to-face interviews, and create focus groups to understand what is the value for customers and how they make this decision with respect to your customer service level. You may have questions like, if we deliver next day instead of next week, would you buy? How many you will buy? Kind of question, and each one of those will correspond to your customer service level. Let's say next day delivery will correspond to 95% customer service level for you, whereas 1 week corresponds to 60%. So you can kind of try different numbers, and you can always look 2, 3, 4, 5 days, and you can look at different aspects of customer service level as well while you are creating the questionnaires. Okay, now as I said, what we are gonna do with this approximation of 2-point methods is we are looking at the diminishing return area. Okay, and we are basically, we have 2 points, and based on these 2 points we are drawing a line. Sometimes this line is going to be over the actual sales curve, and sometimes it's going to be under the sales curve. But since we don't have a good method of drawing this actual curve, we have to go with what we have. Okay, now so far we just look at the revenue and customer service level, but companies really don't care about the revenue if you are not trying to dominate the market. The most important performance metric for you is the profit. So when you are trying to decide what should be your customer service level, you need to focus on your profit more than the revenue, because you can always increase your revenue with, if you are not going up to the decline area, by increasing your customer service level. But if you go back to my initial example of 1, 2, 3, 4 employees, let's say you pay $100 for each day. When you have 1 employee, you pay $100. When you add 1, you pay $200. You add 2 more, you pay $400. So initially, it was cheap to increase your revenue, but then as it is shown here, you have to increase more customer service level to get the same revenue increase. Okay, so it is really expensive to improve your customer service level until after a point. We need to focus on profit maximization. Okay, in this graph, this is my logistics cost, which affects my customer service level. Okay, it could be on time delivery, response time when I have urgent shipments, okay, and fill rate, what percentages of customers are coming to my store and finding the product in the store, my not the warranty, my I'm just trying to find another dimension of customer service level where we can just put it here. I'm just gonna skip that one anyway. When I remember, I'll come back and talk about it, another dimension. But usually on-time delivery, response rate and fill rate are very well established customer service level. And in terms of logistics inventory, we will focus on fill rate, which is easily measurable. Okay, now in this your cost increases a lot. Initially you can spend a little bit money. Let's say I'm gonna spend this much money. Okay, this is the money I am spending, and I get this much improvement. Okay, for the same amount of expenditure, later I'm gonna get less customer service level improvement. Okay, this is my improvement, this was my improvement. Okay, so the cost increases in a different rate, and revenue is going down in a different rate. But my maximum profit is at the point where the increase in the logistics cost is equal to the increase in the revenue cost. Because after this point, I know that increase in the revenue is going down, and increase in the logistics cost is going up. So at this point I have the maximum. If I go further in this customer service level, I'm gonna lose money. If I go beyond this point and offer a little bit less customer service level, I'm losing an opportunity to make a little bit more money from this business. So that is the place I need to find where my cost is equal to my revenue or profit increase. Okay, so let's look at that relationship. Okay, as I said, what I need to find is delta P, basically marginal profit increase and delta C be my logistics, but it needs to be again marginal cost increase. Okay, and maximum profit is at the location where I have delta P equal to delta C. Okay, at this point I maximize my profit. Okay, I'm just going to put some information here. For delta P, you can calculate delta P as trading margin, how much money you are making out of each product or each unit. It could be volume if you want, trading margin. And this is, I'm gonna think about countable stuff, thinking units. And if you have volume based stuff, then it is per unit volume. Okay, and multiplied by sales response rate, which is basically percentage of sales increase when customer service level is increased by 1%. Okay, so if I increase my customer service level by 1%, how much sales increase I will see. Okay, and that is the slope of that line. Okay, basically slope of this line. And then I need to multiply that one with my annual sales. Okay, and in a similar way I'm gonna write my delta C, which is my marginal cost. I need to know my inventory holding rate. What is the percentage? Okay, and I'm gonna put annual, so you may want to consider that one as annual, and this is gonna be percent per year. Okay, since I put the annual, the important thing here is this annual sales and this inventory holding rate, they need to be in the same unit. So if you can use your monthly sales, but then you need to consider monthly inventory holding rate. Okay, so as long as you are consistent in terms of time units, then you would be okay. Okay, standard product cost, how much it costs you. This is again dollar per unit. Okay, the next thing I'm gonna put just here and continue below. Okay, the next one is this standard deviation of demand. Deviation this is gonna be D as well, right? Demand during the lead time. Okay, now this lead time concept is important. Lead time is basically measured from the time you place your order to the time you receive your shipment. Okay, and this is multiplied by a term called delta Z. Okay, now delta Z, I need to explain something here. What we are assuming here is that demand is normally distributed, which means if I draw the demand distribution per day, per year, per month, I see something like this. Okay, this is my mean demand, and I have a standard deviation of demand and so forth, but demand is something like this. Okay, and you may have a different type of demand. In that case you need to consider some other stuff, but which we are not going to cover. I just assume that the demand is normally distributed, and statistically speaking, if you have a really big population which has more than 30 units of measurement, then you can comfortably assume that that is normally distributed. Okay, so a normal distribution is nice because we can fit everything. Okay, now I'll just solve an example and then we will continue. Now in my example, I would assume that trading margin for this product, is $6 per unit. Okay, sales response rate is 0.2%, and annual sale is equal to 50,000 units. Okay, and on the other side, my inventory holding rate is 25% per year. Okay, cost per unit, cost of each product, cost of buying, okay, not your selling cost, cost of product is $40 and then standard deviation of demand, per week is 500 units, and my lead time is 1 week. Okay, so my objective is solving this question. Okay, now first I'm gonna start with delta P, and delta P was trading margin multiplied by sales response rate and multiplied by annual sales. So $6 and 0.2 and 500 50,000. Okay, I made a mistake here intentionally. I get sometimes this mistake where when you put 0.3%, that is actually 0.2. So be careful about that, not to put 0.2 as a percentage, okay, value. So make sure that this is depicted in a right way. Okay, so the actual way of putting it is this way, and that is gonna be equal to 600. Okay, and now I'm gonna calculate my delta C. My inventory holding rate is 25% per year. Okay, this was per year, this is per year. I am okay. Okay, and then I have $40 for each unit. My standard deviation of demand per week is 500. Luckily my lead time is 1 week, so this week and this week are aligned in terms of time units, so I'm safe to go. I'm just gonna do it with 1 week, and then I'll show you what happens if it was 4 weeks. Okay, but we'll do it in a week, in a minute. Alright, and that is multiplied by delta Z. And if you go calculate delta C, that is gonna be 5,000 times delta Z. Now I need to find this delta Z. Okay, and I know that this delta P equal to delta C, and if I write 600 equal to 5,000 times delta Z, I can find out that delta Z is equal to 0.12. Okay, now the good thing about this one is once you have this 0.12, you can go and check some tables. I have a table here. I'm just gonna look at the table first, but I'll also show you how to find this number. Okay, so what I need to do is I need to look at the 0.12 in a delta Z table. Okay, and since I assume that everything is normally distributed, this delta Z comes from the normal distribution table. So I'm looking at the numbers. It seems the closer number is this 97%. So I need to provide 97% customer service level. Okay, because when I switch from 96% to 97%, I have the closest number. Okay, which was, okay, I cannot write with here, but this is my customer service level. Right, and I'm gonna go back to the previous slide and show you what happens if I had 4 weeks, and then I'm gonna show you how to come up with this delta Z tables for yourself if you need to do it, and I'll also show you what should be the really optimal customer service level if you don't want to go with the rounding. Okay, and let's go back. Okay, so I look at the delta Z value, went back to this table, and I found the closest one, and I assume that 97% should be my customer service level. Okay, now the second part of the problem, I said what happens if my customer service level was 4 weeks. Okay, now to do that we need to kind of go a little bit back to statistics. Okay, and I assume you guys are fresh in statistics. Okay, But one thing I'm gonna say is, okay, lead time during the lead time is basically can be calculated as 1 square. Basically, you cannot really add the standard deviation. You have to add the variances. Okay, so you add all of them, and then let's say n week. Okay, this is week 1 standard deviation, week 2 standard deviation, week n standard deviation. But I couldn't calculate directly. I had square, which is the variance. Okay, the variance x is equal to standard deviation square. Okay, so that's what I'm trying to do. Okay, and if demand is independent and identically distributed, for the sake of this course, we always assume that demand is independent and identically distributed, which means demand you see this week is gonna be similar to next week, or the week after that, or the week after that. Okay, that is being identical. Independent means if a customer buys this week, in real life they may not be buying again if your pool of customers are small. But what we assume is if a person is buying today, or they will buy next week with the same probability. Okay, if your population is so big, basically some will not buy, some others will buy, but overall you will always see similar numbers. Okay, one way of, in some scenarios you may not see some independent demand where you have forward buying. Okay, basically you offer an discount or incentive to your customers, and perhaps they needed 1 unit but they bought 5 units. Okay, they are not gonna buy next week. Okay, that means the demand in this week is affecting the next week's demand. In that case, you cannot use this relationship. Okay, you have to go through the covariances. But I'm just trying to be complete and not trying to scare you. But what you need to know is basically is this one. I'm just writing again. Square sigma n square. Okay, when I assume demand is independent and identically distributed, that means sigma b1 is equal to sigma 2 equal to sigma n. Okay, which is very nice. If I assume all these are sigmas, then I can show that the standard deviation of demand during the lead time is very easy something. Okay, right, this is lead time. Okay, I'm gonna just go one more step and just say, okay, lead time. Okay, whatever the lead time. So in our example, delta C was, I need to go back and remember the numbers, 0.25, 40, 500, delta Z. Okay, when it was 1 week, what I did is basically 0.25, 40, 500. This is per week standard deviation, and I said lead time is 1 week and multiplied by delta Z, and I found 5,000. Okay, now when it is 4 weeks, delta C is gonna be equal to 0.25 times 40 times 500, this times square root of 4 times delta Z. Okay, this is the relationship you need to remember. Okay, so whatever my time unit is here, my standard deviation of demand was given per week, and I have a lead time of 4 weeks. If this was 2 weeks standard deviation, and if this was 4 weeks again, then it would be only 2 times 2, where I would add square root of 2. Okay, I hope you guys are following. If you cannot, just send me an email or give me a call. We will go over this again. Okay, so in that case, my delta C would be, let me complete this one as well, 10,000 delta Z. If I put the this equation, I would find out that delta z is equal to 0.06. Okay, and then I would again go to this table and find the closest number. Probably this would be my closest number. Okay, 91%. In that case, I could offer 91% customer service level to my customers. All right. I hope so you were able to follow up. I'm just gonna post one additional slide video lecture to cover how to come up with this table. Okay, and I'll also show you how to calculate the optimal number.